Interactive character control with auto-regressive motion diffusion models. Recently, diffusion models have gained prominence in motion generation, yet their application in real-time interactive character control remains unexplored. In this paper, we present A-MDM, an auto-regressive diffusion model for real-time motion synthesis, which can produce responsive behaviors to interactive user controls. Our model can synthesize long-horizon controllable human motions that follow user control signal. The model is trained using a procedure based on DDPM.
Our conditional diffusion model takes an initial pose as input, and auto-regressively generates successive motion frames. We can visualize the predictions from intermediate denoising steps after a motion sequence is generated. Our experiments with diffusion models with varying numbers of denoising steps demonstrate that both the diversity and the ability to model complex motion improve as we increase the denoising steps. However, the benefits of increasing the number of denoising steps begin to plateau, and the need for rapid inference takes precedence over further increases in denoising steps. We find A-MDM is able to generate diverse transitions given a difficult initial frame. Furthermore, it is capable of generating highly dynamic motions such as dancing and cartwheel. In a comparison with humor and motion VAE, A-MDM stands out for its diversity. It also more effectively models complex motions such as crawling and sitting. A-MDM can still synthesize diverse and dynamic motion when trained on a large dataset such as human ML3D. Additionally, our model is able to generate long horizon motion. This task is challenging because human ML3D primarily consists of short motions. Additionally, A-MDM can compete with the neural state machine in generating locomotion, modeling the turning movements of a character more naturally.
Diffusion model-based inpainting techniques are also amenable for A-MDM. Our A-MDM can synthesize high-quality motions that follow a target trajectory through conditional inpainting. Conditional inpainting allows us to use A-MDM for new tasks without any additional training. Our framework can perform motion in betweening and follow time varying pose targets in a real-time manner. With a series of buffer frames, inpainting can generate seamless motion transitions between arbitrary character states and user-specified motions. We can train task-specific high-level controllers to steer the denoising process of A-MDM to produce motions that satisfy desired task objectives. Our framework can follow time-varying targets in a real-time manner. With hierarchical control, A-MDM can also synthesize diverse motions to reach given targets, with the same initial state and task observation. Our controller can generate motions that follow commands from a joystick. Our controller can also follow a user-specified path. After training a hierarchical controller, our framework can follow arbitrary trajectories in real time, without the need for any additional optimization. With a natural user-specified velocity, both inpainting and hierarchical control can generate realistic human motions following the user-specified trajectory. However, with an unnatural target trajectory, for instance, an extremely slow velocity, hierarchical control offers greater flexibility and is capable of generating more natural motions.